Anfang 2008 veröffentlichte ein Mitarbeiter der Library of Congress die Subject Headings als Linked Data als Experiment im Web. Im Dezember 2008 forderte sein Arbeitgeber, die Library of Congress, ihn auf, diese Daten wieder aus dem Netz zu nehmen. Der Mitarbeiter ging dieser Forderung nach und ein Aufschrei ging durch die Welt der Bibliothekare, die sich mit dem Semantic Web beschäftigten. Viele hatten nämlich ihre Daten mit den Subject Headings verknüpft. Und zum Glück wurden diese Daten im Mai 2009 wieder veröffentlicht, diesmal von der Library of Congress selbst, und stehen seitdem der Öffentlichkeit zur Verfügung. Und Herr Haselhofer hat in seinem Vortrag auch schon bereits darauf hingewiesen. Der Mitarbeiter, von dem hier gesprochen wird, heißt Ed Summers, und er ist heute hier, um uns mehr über dieses Projekt und andere Semantic Web Projekte der Library of Congress zu berichten. Die LOC möchte nämlich nicht nur auch die anderen Normdaten so zur Verfügung stellen. Ein anderes Projekt ist Chronicling America, einem Online-Archiv von 1,5 Millionen historischer Zeitungsseiten, und auch diese Objekte sollen als Linked Data publiziert werden. Ed Summers hat außerdem beim B3C bei der Semantic Web Deployment Working Group mitgearbeitet, sehr stark auch mit SCOS, was hier schon mehrmals erwähnt wurde. Und er wird uns nun zeigen, wie man bestehende Web-Technologien einsetzen kann, um Linked Data verfügbar zu machen und auf welchen Gebieten noch Entwicklungsbedarf besteht. Thank you, Ed, for coming, and it's yours now.
Thank you very much for inviting me. I'm going to be speaking in English because unfortunately I can't speak German. So I hope that you can at least understand some of what I'm going to say, since I'm going to speak for an hour. But actually, I'm going to try to speak a little bit, leave time for questions and not impinge on your lunch. So yeah, like I said, it's a real honor to be invited here today because, you know, I will be speaking in a foreign language, and I've never actually spoken to a, you know, a completely foreign, another group of people that don't speak my language. Or I'm not sure I speak my language either. And also, I don't know, but I think this might be one of the first Semantic Web library conferences for 2 days that I've heard of. So I think I'm excited to be here today, and I think that you all should feel excited for what you've put on today, because I think this is the first one, and so you guys are kind of way ahead of the pack as far as I'm concerned. The fact that you're here today, listening to the speakers that you have, is a really good sign. I kind of reworked the title of my presentation a little bit. And basically what I'm going to try to do is so a lot of the talk about Semantic Web seems to be about tomorrow, and while it is really exciting, you know, to think about all the possibilities that there are, I think it's also important to think about the past and how we got to where we are. And I think that Jacob, from what I understood of Jacob's talk, he covered quite a bit of this material. So for that, I'm grateful, because you will have been introduced to it in a much more clear way. And you know, one of the key things about Web 1.0 is this idea of HTML, or this standard called HTML, Hypertext Markup Language. Could I see a show of hands of how many people have written an HTML document in your life? Okay, that's great. This is an example of an HTML page, Cologne in Wikipedia. And in that page, you know, you've got some text that's larger than other parts of the HTML. This is obviously going to be a review for all of you. But you know, this is a markup for marking up the presentation of the word Cologne in that page. And you've also got up at the top there's a little bit of text saying Cologne, Wikipedia, some This is actually, the browsers decided to extract a bit of metadata from the page, the title of the page, and use it in that particular way. So you've got both presentation markup and metadata markup kind of mixed together. And you've also got links to other things. So in this case, I've circled the rhyme. This is a link to another page. And that's a familiar way of marking up a link. And that when you click on that link, you go to another page. In this case, the rhyme. And the thing that really makes all that happen is the URL, and that's the Uniform Resource Locator. And these are examples of the URLs that we just saw in action there. And this is kind of a representation of sort of the data model that's sort of behind the web. So here we have like a graph of two documents that are linked together. And you can link out, in lots of different ways. And basically, this is the graph data structure that is the web. And as we'll see, when really all, I was at a talk a few weeks ago where Tom Baker, who works with the Dublin Core Metadata Initiative, talked about RDF as really just a grammar for links on the web. And that's actually the simplest expression of what I can think RDF is. If you're ever finding it hard to understand what RDF is, it's really just a way of describing what you see up here on the screen. So it's really not that different. And obviously, you probably can't see, well, nobody can see this, but this is 5 levels deep from history in the Wikipedia that someone put together. And so, we have these, this is just 5 levels deep in Wikipedia. Very incredibly rich graphs. And, not everybody, we don't actually, well, in the case of Wikipedia, people did actually enter in that content, but a lot of the linking is done by the mechanics of Wikipedia. And certainly every time you get a page from Wikipedia, there's not someone typing it in behind the scenes. There's a database of some kind, which is consulted and used to present the HTML. In fact, this is kind of my personal history. When I first started using the web, I used this Perl programming language and this CGI module. Has anybody used this before? Wow, okay, great. So, this was my introduction to the web, was like, wow, I can use this Perl module, and I can use this other Perl module for talking to a database, and I can create crazy monsters like this. No, I'm just kidding. But this is an example of a URL that's live at the Library of Congress for an item in the catalog. And it kind of gets back with Tim Spaulding's quote about, he wished that items in catalogs were referenceable. And the reason why they're really not is because you've got things like this at the Library of Congress. But really, it was a powerful thing to be able to create a little program. In this case, it was this, somebody created a CGI script, pwebrecon.cgi, and then they have, it's passed a bunch of arguments, as input, and then it generates a web page. But, a few years later, we saw the rise of these web frameworks. So, and there's a rich collection of all these different web frameworks that you can use, basically to take a lot of the drudge work out of web development. So it does a lot of the work for you. And one of the nice side effects of these web frameworks is that almost uniformly they offer this idea of what they call URL routing. So you route a URL pattern to a piece of code. This is an example of a Python route. But this idea exists in a lot of different web frameworks. In this case, we're mapping a URL pattern that has an LCCN, which is a Library of Congress control number, to a Python module called views and a function within that called item. And so what that allows you to do is to take what used to be a URL like this and turn it into something like that. And that's the LCCN there. So the reason why this is important is that, and Jacob talked about this as well, this idea of cool URIs. The reason why cool URIs are important is because you want to be able to swap out your technology. You know, when some piece of software goes out of date or isn't being maintained anymore by some developer somewhere, or your vendor decides to, you know, can it, or you know, a variety of things can happen. The simpler your URLs are, the easier it is to not migrate that change and everybody's links don't break. And another idea, really core idea of the web is this idea of REST. REST is really, it's the architecture of the web. Roy Fielding and Tim Berners-Lee both worked on this hypertext transfer protocol standard together. And Roy went on to write his dissertation about, you know, what they did with those standards that allowed the web to scale to the degree that it did. And it's basically just the idea of getting using identifiers and to identify what he called resources. So REST is resource state transition. Is that right? Or representation state transition. I always forget. But it's a really important idea because it's at the heart of how the web works. And this is basically a diagram of the different states that a request can go through. You basically have get and post, which a lot of you are probably familiar with. Your browser kind of does this natively. When you get a Wikipedia page, you do a get operation. And when you update a form or whatnot, you often do a post. And put and delete are other operations. Put allows you to create resources, and delete deletes them. You see these less often, but they're important. So I was a web developer. That's kind of like my sort of history as a web developer, how I kind of became familiar with the web. When I came to the Library of Congress, this is a picture of the Library of Congress. I work in a building behind this that is much dingier, and but this is the kind of nice old building. When I first got there, I happened across a paper that Barbara Tillett wrote with Corey Harper, who's at New York University, and they talked about ways of taking Library of Congress data assets and putting them on the web in a more meaningful way. And so this kind of, I put this here because it kind of caused a paradigm shift in my head a little bit about thinking about the web and library data. And it really made me sort of look backwards at the Library of Congress, its own history, and sort of think about how it is that the web could fit in better with what the library was doing or had done for the last century. So this is a picture of Library of Congress. I think it was in the 1880s. It was basically a room off of the Senate building of the Capitol, quite small. In 1878, I think. I'm sorry, my strength was never history, so I'm going to be vague about dates. Hopefully you're okay with that. But basically in the late 1800s, the copyright law changed in the United States, so they wanted to establish a copyright office. And as a result of that, they wanted books deposited with the copyright program to be put in a library. And so they constructed that building that I just showed you. When they opened the doors, they had a lot of books coming in the door, and they had no way to organize them. So that's a picture of what it looked like in one of the hallways. Complete mess. Luckily, this guy, Charles Cutter, was writing at that time. He worked at this the Boston Athenaeum in Boston, Massachusetts, in the United States. And he was part of kind of a long lineage of people that thought about catalogs. But the thing that he did, which was different, was he just wrote down his rules, basically, for what became known as at least in the United States, this card catalog system, where there's 3 filings for subject and title and name. And so, yeah, these are examples of some cards. This is a card catalog. This is actually at Yale University. But the idea really took off. And one of the reasons why it took off was because, at least in the United States, all those items that were getting cataloged as part of the Copyright Office, they printed cards for them, not only for the library, but for anybody that wanted to buy them. And so this was a room where they were pulling cards to send off to libraries around the United States. And this is a printing machine that they used to print the cards. This woman is Henrietta Avram, who in the 1960s, as the printing process became computerized, they needed a way of representing the card in machine-readable form to give to the printing machines. And so she came up with this mark standard, which looks like that. Yeah. And what that enabled was, once the data was in, once this information that's on the card was in electronic form, it allowed you to create computer programs, basically, that acted as the catalog. So this is Oxford University. I don't know if this is still alive or not, but it was there, sort of OPAC. And when the web came along, we created basically the same thing, but with web pages. This is actually supposed to say Web 0.1, so I'm going to move even further backwards, I guess. So it I started thinking a little bit differently about the history of library data, at least at the Library of Congress, and I also started thinking about the web a little bit differently. And so this was my introduction to kind of looking back at the origins of the web. This is Tim Berners-Lee's computer that he first ran the web HTTP server on. And we saw this in Jacob's slides already. This was part of Tim Berners-Lee's diagram for his proposal to start building out a lot of these, what became HTTP and HTML and URLs. And the important thing to note here, and I think Jacob pointed this out, but the neat thing about this diagram is that links aren't just all the same. There are different kinds of links between documents. There's links that are this resource describes this resource over here, or this are partitive relationships, like this resource is part of this other resource. So the linking was much richer in this original idea for the web. And he wanted to use this system called Dynatext for initially at CERN, and he couldn't because there was some pricing stuff involved in it. It had some model where every time you accessed a document, you paid a little chunk of money, something like that, and it just didn't fit what they wanted to do at CERN. And it's also important to note here that Tim Berners-Lee was trying to organize documents, which is a function that we often think of libraries as doing. So he's trying to organize the scientific documents and publications at CERN. And the idea of hypertext goes back even further to Ted Nelson, who actually coined the term hypertext. And he had this idea of Xanadu, which was a massively distributed web of documents that had some extra stuff in there for actually very similar for pricing, to enable authors to get money when their documents were accessed. But, he's kind of Tim Berners-Lee drew heavily on his work. In the 1960s, there was this hypertext editing system that Ted Nelson worked on at Brown University as part of a group. And around the same time, Doug Engelbart at Xerox PARC in California he did this mother-all, it's called the mother of all demos. I think that's what they called it, like looking back, because he demonstrated a lot of technologies we take for granted today, including like the mouse and email and document editing and hypertext, although he didn't call it hypertext. And the idea, this hypertext idea, goes back to Vannevar Bush's idea of trails in the 1940s. Again, he was trying, the scientific publishing was kind of going gangbusters. People were publishing lots of scientific material, and they needed a way to organize it. He sort of envisioned this idea these kind of crazy microfilm readers that would allow you to connect up different pieces of documents. And going even further back to the late 1800s, mid to late 1800s. Yeah, that's a big one, right? Paul Aulet, who I guess is was over in Belgium and Brussels. He had this idea of a repertoire bibliographie universelle, and basically this was a very rich card system for linking together facts with documents, people's names, subjects, all using this universal decimal classification that we came up with. So we trace the web back far enough, we actually end up sort of eating our own tail. Where, it's a the web and libraries kind of have this history that's kind of tied together. So I read that paper of Barbara Tillett's, and there was instructions in there like how to create SCOTs from Library of Congress subject headings. So I was like, I'm a web developer, I can try to do that. So and Barbara Tillett got me involved in the SCOTs working group at the W3C, and they were basically looking for someone to kick the tires on the standard and see that that it could be used to model the subject headings. And I think Bernhard described this already, so I don't probably have to do it again. Oh, that's the paper again. So basically, here's an example of a concept for World Wide Web, and it has alternate form, which is that UF. It's a use for, and BT is broader term, and NT is narrower term. And these are basically links, or standard thesaurus kind of constructs. And so I ran across this SCOTs standard, and so I read about it, and I also ran across a very important document that two guys here in Germany actually created. This is the cool URIs for the Semantic Web. This is really nice because it kind of described just the mechanics of how to put, if you are going to put stuff on the Semantic Web, here's some simple patterns you can follow for doing it. And so this is basically what we did with subject headings. We just, you probably can't read this at all, but the three boxes are the circles are concepts for things that are in the subject headings, and they're related together. And this is the same kind of diagram we saw all the way at the beginning, except the arrows between the things are much richer. And this is basically the RDF data model, that kind of visual form, which can be represented in lots of other ways. But really, this is the important thing. What it looks like in RDF XML, it's important, obviously, that it has that representation, because computers can read RDF XML better than they can this. Probably better than we can read this right now. But and the thing that we did was we just put URLs onto those circles, those concepts. And when you resolve that URL, you get back an HTML page that describes the concept, World Wide Web. It has links in it to narrower and related terms. This is a way of sort of, Bernhard mentioned this. The exciting thing about when we put it up at IGLOC.gov was that Antoine Isaac at Free University in Amsterdam went through the effort of mapping Rameau vocabulary to Library of Congress subject headings. And he gave us that mapping. And so we made links from our concepts to Rameau's concepts. And so what this did for us was we got French translations of a large portion of our subject headings, which is it's a useful thing to have. And, if you resolve those URLs for Rameau, you end up on a site that Antoine put up. It looks like that. This is the same concept, World Wide Web. We also, this is the same example, but with a more interesting term, because World Wide Web kind of is the same in different languages sometimes. This is free trade, and so in French it's libre-échange. Now, one thing that we could do is we could think about linking out to Joachim's thesaurus for economic terms. And so in this example, we could, because, and we'll probably hear tomorrow more about that, but we could do the same thing. We could get German, equivalent close matches to our terms. And actually, the thesaurus for economic terms has English labels in there as well, so we could use those to match them. And this is an example of Joachim's page for free trade, the German version of it. And one nice thing that is present in that data set is that Joachim's gone through the effort of mapping his terms to Wikipedia, where there's I think this is Chinese, Chinese label for free trade. So suddenly, by just doing a simple link out to someone else, you get such richer data. And people talk about what the killer app is for the semantic web, and one of my friends, Roy Ten, in the United States, is always kind of giving me a hard time, like, yeah, where's the killer app for the semantic web? And I'm glad that he does it, because I think it's important to focus on, what's the good benefit for the end user. But as a programmer, seeing the data get enriched this way, it's a very powerful experience. And so, and it doesn't involve any, unicorns or, magic. It's just kind of following your link, to somewhere else. And actually, the hard part is creating that link. But going to Wikipedia then opens up this wider universe of data sets, which Bernhard talked about. And I thought that it was important just to point out that the technologies that we used were just standard web technologies in a three-tier kind of system. We used a database, MySQL, and we had Python code that was running Django, and Apache, which is a very common web server. We didn't use a Sparkle, triple store, whatever. We didn't have to do that to start doing this. And I'm not saying that you shouldn't investigate using triple stores and Sparkle endpoints, but I guess the point is that your developers can continue using the standard technologies that they're comfortable with and still get presence in this data web. So another project I was going to talk briefly about. How much time do I have left? 15 minutes? Okay, so I'll move really quickly. This is a project at the Library of Congress to do, to basically digitize microfilm from around the United States for old historic newspapers. And it's a 20-year project. And one of the side effects of this project is that there are URLs for newspaper titles. This is a calendar view of the newspaper title. There are URLs for issues of the newspaper, and there are URLs for pages within that issue. And there are also URLs for batches, which are very special kind of data packages that we get from people around the country who are giving us newspaper data. And so what we have behind the scenes is a relational database, that models that kind of stuff, titles, issues, pages. But what we wanted to do was publish that data out to the web so that people could harvest it. And not only harvest the metadata, but harvest the actual objects themselves. So the TIFFs and the JPEG 2000s and the OCR XML files. And so this object reuse and exchange vocabulary came in really handy because it's basically an extension of the OAI PMH protocol for making not only the metadata available, but the underlying resources of being described. So this is a model of the kind of stuff that we have modeled in our database. And we've actually linked out to DBpedia for places. So, and by doing that, we learned little things like so this is the newspaper New York Tribune, but we learned that New York has a population of 8,363,000 people, and its nickname is the Big Apple. But I mean, these are just an example of the facts that are in DBpedia that we didn't have in our database. But by virtue of linking to DBpedia, we kind of can get them out. And more interestingly, DBpedia links out to GeoNames, which is a site that has very detailed geographic information about places. And if you go to follow the link that they have to GeoNames, you get this nice maps and stuff like that. And if we wanted to, let's say, we haven't done this yet, but if we wanted to build a search interface that put search results on a map, we could use the information we've harvested out of GeoNames to do this kind of work. And also, we've got a Flickr project going on at the Library of Congress where we're putting selected content up on Flickr so that people can interact with it there instead of on our boring website. And so this is an example of a page that's put up on Flickr. So we persist that in our database, using kind of remembering the identifier of the Flickr resource. And we're not by any. I was glad Bernhard did this because he gave a really nice overview of all the stuff that's going on. It's a really kind of exciting space right now, and hard to kind of keep tabs on all of it. But Patrick Hoschenbach, sitting in the back there, he has. I mentioned this because it also uses ORE vocabulary to make data available for his universities. All the research output of the university. So I guess I wanted to close with Dan Brickley, I guess, used this slide at the UDC conference a few weeks ago. And he asked me if I could use it today, just to, like if you're talking about, I mean, I guess it's in English, we could translate it to German maybe, that would be appropriate. But basically, this is a logo that was used at the beginning of the web to get people to start putting web documents online. As absurd as it might seem now that anybody needed any encouragement to do it. I think there's the thing I wanted to close with was that if you're a manager and you're interested in sort of getting more involved in this linked data effort. You could think about things that your library or institution has that are unique that you think other people might want to link to. I think national libraries are in kind of a unique position there because of their role, but I don't think that you shouldn't, if you're not from a national library, I think that you definitely have things of value that you could put on the web for other people to link to. And also you might want to take a chance with, if your software developers have an idea which sounds a little bit crazy, maybe give an opportunity. It was funny to hear Tim Berners-Lee when he gave his manager that document proposal. I think his manager's response was exciting, or vague but exciting. He wrote that on the proposal. But he gave him a chance. And if you're a developer, think about the resources that you're putting up on the web every day. Think about making machine-readable versions of those resources available. Keep your tabs on stuff going on like RDFA and HTML5 because these are new ways of putting RDF data model data onto the web. And look at linking to other people to get sort of new facts about your data that you didn't know before. And if you're a researcher, we need help figuring out how to link resources together in an efficient and while retaining quality. And also, if you're a publisher, it's hard to know sometimes when your data is being used in somebody else's data. So mechanisms for publishing that, making it easier for a publisher to know when their data is being used services that allow you to do that. Some sort of distributed way of doing that is important. And also, I think that there's a discussion list for linking open data, which it will be great to see more discussion from library, people in libraries on there. Also, I think it would be great to see more discussion in German. And you know, if you're, I think it's important that it's not just an English venue. That you know, because the real power of this linked data stuff is connecting up data across these boundaries. And that's all I have for you. A bunch of image credits. I'm sorry for going on so long. I had 100 slides, so the fact that you're still awake at all is amazing. But I'm happy to take any questions if there's any time.